Yeah, I'm super excited to be here to talk about this. I'm Sean, and I'm a principal engineer and a technical advisor here at Netlify. You can find me on a lot of social media, and yeah, I've been building web systems for the better part of 2 decades now, so I've been able to see some interesting stuff. It might be fun to go back to the CFE kind of archives and see how it was a while ago. But yeah, and I've been able to help make some really great experiences across the web. So, and at Netlify, my focus is working across the platform and the product to with a keen focus on web architecture and web performance and nowadays more web first AI type systems. Yeah, so let's dive into it. So. We're on the downhill of 2024. So all of those aspirations we had on New Year's Day are looking like we're going to have to start reestablishing them for the next year. But this is definitely a fun and exciting time of year. And there's a lot of different things on people's minds this time of year. Hopefully, we're all able to stop and identify the things that bring us energy and show gratitude for those people and those things. My favorite aspect is definitely being able to catch up with loved ones we don't get to see most of the year. For many, a big highlight in November is going to be that time to get some excellent food. And of course, Black Friday and Cyber Monday are on lots of people's minds. And I bring this up, because at this time of year, at Netlify, this is what we're spending a lot of time thinking about. Not because it's the time to buy a bunch of gifts, but because Black Friday and Cyber Monday represent, a really crucial moment for our customers and the community that we're serving. And in retail businesses this time of year, a large number of our customers, right, are online retailers. And so if you want to get some bands this time of year, you're definitely going to be benefiting from all of our focus to make sure that those sites are able to maximize those key opportunities. And what I mean by those key opportunities are, like Black Friday, or if you're launching a new product, or you've received an award or a bunch of attention, and you get this influx of unexpected or expected traffic to your site. You're wanting to capitalize and make the most of that moment. Black Friday might not be your moment. It could be many different things, but what's true across all of those moments is, you want to be able to build systems that can meet the demand in a way that captures as much of that opportunity presented to the business or the site as possible. And this is really the focus of this talk today, not just the technology, but the intent about why it exists, right? And allowing developers and customers to maximize the ability to capture full opportunities that come to their sites. So when we're thinking about these opportunities, the big thing is handling scale and resiliency, right? But let's assume for now, right, that you've covered the basics, right? With you're able to scale up automatically where possible. You set out some target and to ensure that you're able to handle at least that much capacity and throughput on your system. Most serverless offerings, especially including those at Netlify, make this pretty trivial. But ultimately, what we're looking at past that is how you handle unexpected or these transient challenges, right? Things that they're probably out of your control, and you need to capture. You still want to be able to capture as much of the opportunity, even though something is happening. And there's many ways to go about ensuring that, but a tried and true method for handling these resiliency challenges is leveraging event-based architectures and durable compute. And what we mean here, right? So event-based architecture, if you're not familiar with it, it's that ability to use events instead of one-to-one mapping between a server transaction call to an endpoint. You're essentially broadcasting an event, and things are listening for that event or subscribe to it, and we'll run a process, reacting to that. Those architectures have unique, different qualities to them that a traditional server doesn't allow. And here's just some of those benefits there. And on the durable compute side, this is where things get really interesting. Is especially in a serverless environment, right? You want to be able to ensure that when things go wrong, the system will continue despite that thing happening, right? So if a problem crops up, you're able to pick up and continue forward. Let's take an example of like maybe a key moment where you really wish the system was more durable, right? So if you launched a new website and maybe you had signed up for some newsletter free plan, and that plan is now getting rate limited or something right when you're starting to get an influx of traffic. If you don't build your systems using these durable models and these ways to decouple these transaction models, then whenever you start hitting those rate limits, all those signups, all those attempts to provide you business or awareness or contribute can be lost, right? So we're going to be talking about how we leverage these patterns to, even when those transient issues happen, these unexpected things happen, you're still able to live up to that and have a successful key moment there. And there's lots of ways to achieve durable compute and event-based architectures. You'll find that, like most things, that there's a range of complexities that you can find when you start adopting different solutions for this. Ultimately, the important thing is that you're looking to these types of patterns to solve these problems, to make sure you handle capturing that full moment. And at Netlify, we built Async Workloads, which allows you to create serverless functions that operate using event-based workflows and are durable by default. So this is essentially our take on making sure that our developers in our community have the tools that they need to have resilient sites beyond just being able to scale, but also being able to capture moments when things outside of scaling problems come into play. So what we're going to do next is we'll walk through a bit about how this works, and I'll cover some details about how these systems, abstract a lot of the complexities going on from queuing, retries, and orchestration. And from there, we'll actually examine how this applies to a real-world scenario that captures a key business moment. So within Async Workloads, as I mentioned, this is going to be an event-based serverless architecture. So we'll be sending events and subscribing to events. It's durable by default, so it'll have persistent state that allows you to retry and continue forward. In addition, it will allow these multi-step workflows that have these, whenever, if you have 10 steps and step 5 starts failing and then you retry, you don't have to do the other 4 again. So there's a lot of really cool things that happen there. It really expands the window for logic as well. So like being able to say, I want to notify this user after they sign up. I want to notify them in 7 days that they need to upgrade to continue, whatever it is. That ability to write logic that will run in 7 days and not just have something that's sitting there waiting. You will see that when we put it in the logic, it's really just saying, in 7 days, do this thing, and it will just do it for you. And then if total failures are happening, let's say you have a multi-hour, multi-day outage or something wild is happening, all this work is still persistent, right? And so like when those things are resolved, those events and such can be retried. So that's what it's doing. We'll walk through and show what that actually looks like, and then apply that to a scenario here. So let's move over now. So, the first step, whenever you're kind of setting up async workloads, it's really simple. We recently launched our new extensions in our SDK v2. And if you go to your site, or your team rather, and go to extensions, you'll find async workloads, and then you can install it from here and configure it. I've already installed it, but this is all that you really need to do. And then when you go over to the code side, we can start writing these async workloads. And let me pull up my terminal. Great. So in my terminal here, I have just getting some bearings here. This area here is my running local server. And then any sort of additional commands or calls that I want to make, I'll make it down here. So this will be triggering things, and this will be reacting, or how those things are reacting. But we'll get more to that. Okay, so first of all, this is the most basic serverless function. There is, nothing really unique going on here. This is just, if you, set up Netlify and started writing a serverless function, this is probably where you would start. And Netlify makes it super easy, right, to just write this function, and then you can start using it. So if I go over to Chrome, and this is my local server, I invoke this basic serverless function, and it says hello world, exactly as I asked it to. And looking at the logs here, we'll see that my log function down there logged hello from serverless function, this here. So whenever we start creating async workloads, we're going to npm install the Netlify async workloads package, and then we can start building with it. And when we compare these two functions, so this is the basic serverless function that you would call from a HTTP endpoint, and this is the basic async workload function, which is really just a callback that's wrapped in this async workload. And like I mentioned, because this is a event-based architecture, there has to be something that produces an event, and then this is saying that I consume this event and I'm listening for it. So this is all you need to create an async workload function. This is all you need to get durable compute and event-based architecture. That's it. I can't emphasize this enough at how much complexity was removed from setting up various different providers, various different queue systems, and things like that. So whenever we invoke this function, by default, it'll attempt to run 5 times. It will have a back-off schedule, an exponential back-off schedule. It'll go into a dead lettered state if it totally can't work, and then there's an API that you can call to retry it. All of that resiliency packaged up in a very straightforward API here. So now let's actually invoke it. So like we mentioned before on our serverless function, if we went to the endpoint and reload the page, we'll see that it called there. From here, in that same serverless function, we're going to do a workloads client, and then client.send AWL1. So our event name was AWL1, and I can subscribe to many events, but in this case, AWL1, and I'll save that. When I go over to Chrome and reload it, I'll find that the terminal says hello from serverless function, which is the first thing the serverless function says. And then it invoked my async workload, which says hello from async workload. So again, serverless function gets called, it says hello from serverless function, and that invokes this event, which invokes this callback to say hello from async workload. So this is the most basic step for getting a durable event-based architecture on your system. That's it. But if we start looking at more like how this really comes together and why this starts mattering is if we take this example here, which is we have an async workload here that will log the attempt that it's currently on. And then for now, just to have an example of a transient issue that might be happening, we're going to throw an error whenever this is the attempt is less than 1. So we should throw an error twice, and then eventually it'll retry again, and we'll make it to the bottom. So this is called async workload 2. And actually for this, I'm going to hop over to my terminal to make this easier to see. And async workloads comes with a small little CLI that once you've installed the package on your site, you can just start using these commands to just send events to your local server here. And so in this case, I'm triggering an async workload event called AWL-2, right, which is what our event subscribes to. And when I send that, it's going to, right now it's going to, first of all, download the API keys that I need to run, or to make that call, and then it will run it. So let's look at what's happening here. So this is when it started. So we can see that the async workload threw an error, which we expected, error 1, error 2, and then it made it to the end. So if we look at the code here again, whenever we called this, it captured the error. This fails twice, and then it's able to continue here. And you can imagine this could have been any sort of thing. This could have been a fetch to your API. This could have been any sort of, just a race condition, anything that can happen here that would trigger this to cause an error. And then whenever that, the retries automatically happened, and whenever it picked up, it was able to continue forward. And additionally, right, we can set max retries on this to say, I want to retry 10 times, and I can also provide a back off schedule that I can say I want this to, I want this to always retry in 5 minutes, right? We can do something like this. So it's not only can you handle that ability to describe what the system or how the workload functions, but you can also tune how the retrying and all that takes effect. So this is the very basic stuff, but let's go one step deeper here, where this async workloads, they come with the ability to create step functions. And step functions are, these discrete pieces of process that when you run them, you want to only run them once within a given workload. So we have this function that's available to the callback called step.run, and we give it an ID, and then the callback that's going to run. So in this process, we have 4 different steps. This step is going to run, step 1. When it's done, the whole system gets re-invoked, and we do not call step 1 again. And then we'll call step 2, and the same thing, it'll get re-invoked. And now we get down here, and we have something a little bit more complex where we want to run both of these steps in parallel. And so this could be processing a batch of things, and we can say that these are steps, and I want to wait for them to all complete. So let's look at this. Let's invoke this now. And so that was async workload event 3. So we're invoking this, and when we look at our data up here, we see step 1 running, then step 2 runs, 3 and 4 get run in parallel. And this is excellent because this is how, again, how if we have issues, if we're running these 4 steps and step 2 fails, and we'll show what this looks like, then we won't repeat step 1. This allows us to, if we have a computationally expensive task or something that we don't want to continue doing, we could wrap it in a step and ensure that we only do it once. And again, the queuing and retrying, all that's handled for you. All you had to do in this case was to identify what the step was, and then provide the logic. In addition to just being able to define the steps, it also supports serializing the return value. So in step 1, instead of just logging it, we're also returning this string that says, 1 return value. And then step 2, the same thing. We're returning 2 return value. And then same for 3 and 4. In addition to just each step is returning different things, you'll see in step 2 and 3 is that we're actually also logging what value we got from step 1. So in these async workload functions, these are discrete steps. But when a step that has not been completed completes for the first time, the whole workload gets re-invoked. This gives each step a clean slate. But even though that we're re-invoking those full workloads, we're not losing the context of what happened in previous steps when those values are returned. So we can look at this here. Go here, or async workload 4. So when we invoke this, we'll see that step 1 runs, then step 2 runs, and then it also logs, again, what the return value was from the first step. And then same for step 3, it runs and logs what the return value was for step 2. And so this really allows you to compose really complex and really interesting workflows by defining these discrete steps. And lastly, I'll show one more parts about these steps here, is that I'm going to, again, add that arbitrary error state. So step 2 is going to fail 2 times here. So when we run this, again, excuse me. Let's see, step 1 ran. We see step 1 ran. We see step 2 started running, but it threw an error. We still got the return value from number 1. And so the whole thing gets retried. Step 2 runs again because it did not need to run step 1 again. So we see step 2, retry, step 2 again. And we still have that value from step 1. And this happens one more time until finally, we stop throwing that error, and then step 3 and step 4 return, all while retaining the serialized responses from the previous steps. All right. On the 2 more quick things, like I had mentioned, that ability to handle how time is reflected in your workflows. In addition to defining discrete steps, you can also define discrete moments that you need to actually wait for something. So we could have a workflow where it's like sign the user up and then sleep for 10 days and send a follow-up email. And this workload includes the full aspect of what's going on. Step 1, the definition of how long it will have waited, and then automatically it will continue after that period of time, which this is currently 10 seconds. This could have been 10 days or 10 weeks even, and it will keep that stored and persisted until the time it is for it to pick up and run. And if you've ever had to build a serverless setup where, or really any setup, if you're hosting your own servers or not, where you have to do something in weeks ahead of time, weeks in the future, and still retain access to information about what happened weeks before, that's a tough challenge, and it gets complex really fast. Excuse me. And the last little note here is you can also create your events to be fully typed. So in this case, we're saying that I have a workload event. This is the name for it. This is the event data. And so we can see that the event data inside the workload is fully typed, and the things like event filters, and even if I change this to be something else, we're going to get an error because that's not the correct value for this event. On the client, like we mentioned before, you can also type these. So this would be importing my typed event, and we're seeing that I can't send this type. And so this really, if I were able to send this, and then also if I had required data, I didn't have any data that was required, it was all optional, it would also say you also have to send the data along with this. So this is really powerful and really makes for these composable workflows to work really well. So let's swap back over to here. All right, so that was the core functionality around async workloads. There's a lot more that it can do, but I'm not going to continue looking at that alone. But definitely hit us up. Our documentation has so much information on how to really leverage these things. But let's tie this back to November and coming back to one of the most critical moments for web businesses in November, and see how this applies to Black Friday and Cyber Monday. And specifically, there's a lot that really goes with e-commerce, but we're going to take the one of the hardest and arguably the most important part, which is the checkout. There's a lot of things that happen at checkout. Like, this is really high level hand waving, a lot of the micro nuance that goes on here, but I think it will illustrate the point pretty well. So when we're checking out, we need to create that order, reserve the inventory, process a payment, and then update the order once it's complete, and then finally send that receipt. How hard could that be, right? Like, what could go wrong? There's many different things here that, some things are more obvious and easy to test for, and some things are hard, or rather they only really surface once you start getting to that level of load or any other sort of externalities can come to play. Just a few examples, you might have an API that you're using that has a region outage. You might have, you're getting rate limited by something because you selected a free tier, or, maybe someone who signed up for the API key didn't realize that it was going to expire on, the day before Black Friday. I was working in e-commerce, or one of my first jobs working in e-commerce. Someone had inadvertently deleted all of the categories in an e-commerce shop, and that didn't delete the products, but all the category APIs were just gone, and that caused a lot of different issues in an internal process, not just the ability to find the products, which was fine, but really when you started purchasing and bringing things together, internal systems would start to break, and then we would lose those sales until we got that whole thing resolved. It's those things you do not expect, and it's being prepared for those moments. So one more dive at the code here. If we were to look at maybe just a very standard, again, and arguably this would be the cleanest looking checkout API you've ever seen. They don't look this good. But again, hand waving here to illustrate this. Like we mentioned, we need to be able to create the order from the cart, reserve the inventory, process the payment, update the order status, and then send the receipt email. Any one of these steps can have issues. Any one of these steps can take 30 seconds to resolve, 30 minutes to resolve, 30 hours to resolve, right? And you don't want to, you're not planning for that fact is leaving literal money in this case on the table. So how would we go from this to leveraging async workloads to make this more resilient and event based? So if what we've done here is move the full workload into an event that is will respond when checkout 2 happens. So what would happen is you have an API endpoint that authorizes the user and things like that. There's some checks and balances that you have to do on the front, and then it will trigger this and say your order is submitted, and it will run through this process, and it will follow up async if it's unable to resolve. This is how pretty much every large e-commerce player that is in the industry does this. It pushes things to the background so that it can work on it, handle issues, be resilient to various different scenarios, but try to, again, maximize the ability to capture that payment at checkout. So just moving it into an async workload was a good step. So again, it will retry up to 4 more times, so 5 times by default. It'll have a back off schedule. It will try to get this checkout to work, and if it completely fails, let's say one of these things just isn't going to resolve in that window, then it will get pushed to like a dead lettered queue, which is like this fatal area of persistence that you can then use the API to trigger retries for whenever the issue is known to be resolved. But we can make this even better, right? Because let's say you had a blip on the processing payment, right? Even though you really want to make sure these are idempotent, you might not want to repeat these processes on retries, right? And that's where these discrete steps come into play, which all we did between those two was wrap this important capability in a step and allow it to run. So in this case, we're still creating the orders, we're still reserving inventory, processing payments, and so on, but now they're wrapped in steps. And so that if I get all the way down to this send email issue and we weren't able to send the receipts, then the workload will again retry on the back off schedule or that you decide or the default one. But it will not redo any of these other processes that have already been complete. And so to really just make sure that the full process gets complete. And then as a bonus, right, we can also say, if we wanted to say, hey, we also want to send a follow-up email a week after someone purchases, obviously you want this to be a little bit more complex, but to wait a week and then do one more step was as easy as saying, I want this workflow to pause for a week, and then this is the thing I want it to do next. And then now it's its own step, which will be included in the retries and all of that. So like I mentioned before, these systems have the core focus around helping provide an easy to understand system that provides resiliency for you and your team to capture the complete opportunities that make their way to your site. And I thought this would be a great time of year to talk about the impacts that it could have in the biggest event in November for retailers, which will be Black Friday, but it's also super powerful for a lot of other use cases to handle, which these other use cases would be really hard to handle within a serverless environment. AI workflows is top of mind right now, but these can really help you simplify how these things work together over periods of time, right? Even ETL data pipelines. So if you're trying to take a bunch of data or user input data, process it, like create embeddings, and then send it to a provider. Those are workloads that are very straightforward to define and have work. And then, again, if there's issues that happen that you didn't expect, let's say you get rate limited from your AI provider or your, any sort of system, it'll continue and pick up after they've resolved their issue. So it's a very powerful system, and it's really about providing our customers access to that event-based durable compute offering that is really essential for maximizing the ability to capture a full opportunity. It's available for all plans and stuff on Netlify to try and just go try it, experiment with it. The docs, and there's a guide that walks you through the basics and how to set up the more complex stuff. And we'll be doing more of these and providing more resources for people to try it out. And with that, I will say thank you. I hope this has been insightful. Yeah.
Awesome. Thanks, Sean. That was great. I've been doing a lot of work with step functions, and obviously seems very, very similar. So I have before I start asking my questions, just put it out to the audience. If you have questions, please just put them in the chat and I will ask them of Sean. So one of my questions was, okay, each of these followed a straightforward path.
Yeah.
What if I needed to make a decision path, whereby, if this happens, if, let's say I run one step and it returns a value that I'm like, if it's this value, go down this path. If it's that value, go down that path. Is that built in, or would I say trigger different events that might do different other workflows?
Yeah. And so it's all built in, right? And so on the steps side of things, what you're doing is you're saying, I have this bucket of logic and I'm identifying it as some ID key. And then, that thing might return a value. There isn't a required order for any of those things to come in, right? So you could have a function that returns a value, and then you can have n number of other functions that you only run those depending on that value. That's totally fine. This is all kind of a runtime dynamic, solution. So you're not configuring all the possible routes and paths ahead of time, which really reduces the complexity. You're just saying, I have this step that I only want to run once, and this is what it's called. And then you just invoke it. And it's just function calling at the end of the day on the async workloads.
Okay. Yeah, because I know when you do step functions, for instance, in AWS, you have to kind of lay out that workflow, and there's a decision point, and it splits off and things like that. It seems like this is a much more straightforward way of kind of doing that. But I just imagine there even in that scenario of you might want to go down a different path if the payment processing fails, right?
Right.
And then go, yeah.
Okay. Right, exactly. Cool. And then especially on the AI agent side, which is where a lot of the use cases that I've been trying to work on come from. It's like, I need this thing to make a decision about something, and then depending on what it's decided, which is very non-deterministic, go do this other thing. And as long as you can identify it, that's the important part about functions. That if you identify it properly, then when retries and stuff happen, that's how it knows that it's already completed something, is by getting a result from something that's already been identified. But yeah, it's really straightforward to do those things on there.
Yeah, for sure. And so curious, how long does the is there a limit in how long I can do that pause? Let's say I have a 30-day subscription thing, and I can set it to just pause and rerun, or is there a limit to how many times it can keep going, or
no limits there? I don't think we set a limit. If we did, I think it would have been a year or something, but that was mainly to prevent people from accidentally doing something like scheduling something for 10 years because I added a zero or something, right? It's more for that accident. But no, yeah, you can schedule something. In fact, the way right now to help automatically clean up things, there's actually an event that happens internally that happens every 30 days. to clean up all the dead lettered stale events that have failed and that you didn't action, so that everything that's in that part of it is still fresh. So yeah, 30 days, 3 months, all good.
Nice. Yeah, because I imagine I think Nick was commenting that he's like, oh, I could use this for handling subscription stuff and
Right.
things like that. So yeah,
Yeah, exactly.
that's awesome. Okay. Yeah. I mean, I think I've seen a lot of this kind of thing, especially like nowadays where with the ability to have these auto retries and things like that is makes it really, really important.
Yeah.
I mean, there's so many different processes. You gave a good example, but there's a ton of different processes. Even like just batch processing was something you mentioned.
Yeah. I
Yeah,
think
I
that
think
a common one that comes up often that like I love this thing for is like if you've ever worked with OAuth and various different token handling, most of them have some sort of need to refresh that token after some period of time. And
yeah.
you want to kick off a flow, get that token, and then say, wait this period of time, or you can just schedule it and say, schedule a refresh token event in this number of days, and it'll just do that. And so like you don't have to, if you've had to keep these things fresh in the background, it's kind of painful. It's like, you have to have something
Yeah.
that's regularly handling this stuff. And in this case, it's literally just saying, get this, give me my refresh token, make this API call in, 7 days, and it's done. Everything
And
else.
can you? I mean, I know it's somewhat predictable, but like, is the amount of time that you set it to like wait? Can it be dynamic, or does it have to be a fixed?
It can be dynamic. Yeah, there's none of that's like again, I think there's a total maximum. I have to look up the value, but again, that's just to prevent people from having accidentally
Yeah.
going something crazy far. But no, you can. It's all dynamic. You can use milliseconds as an integer, or you can use this short string version, like 30 days would be like 30D, like that string representation time.
But I could like if I get, because I know some systems, like if you get a token, it'll tell you like, oh, by the way, this token is good, when it expires. So you could then set the retry to run based on the return value, maybe.
Yeah. And speaking of handling these resilient issues, like if you start getting rate limited and you start seeing back pressure information from an API that says, hey, you have to slow down, you have to stop for 5 minutes, you can actually grab that response and throw there. You can check it out in the documentation, but you can throw a specific error that says retry with delay. So instead of doing the default backoff, you can catch that and say, I'm going to throw an error with retry with delay for the 5 minutes, and then it'll wait for at least that amount of time and then pick up and continue, so that when you get rate limited, you're dynamic to when you continue forward. You're not just retrying and ignoring that fact. So it's all dynamic.
Oh, that's actually really sweet, because I have run into that
Yeah.
where like I'm calling an API, and I get rate limited, and I had to use like a library and stuff to try and figure out how to get it to like pause and wait and things like that. So would be much easier. Okay, that's cool. And I think you all came up with a very simple kind of way to write these. Like as I was mentioning in the comments, like you don't have to learn in AWS world. It's called like ASL, right?
Yeah.
Which is like the way you write in like a JSON format. You write out the whole step functions, and
Mm-hmm.
here you're just writing your code.
Yeah, exactly. Another little
Nice.
powerful little feature that really showcases this is the configuration block that says, I subscribe to this event. You can also provide an event filter, and that event filter will run, when the router is trying to figure out what workload should handle this event. and you have it's a JavaScript function. You can write whatever you want in JavaScript. Like, so you'll receive the event data. So you can say, for example, I want to run this premium feature event, but my event filter, when they send the user, I want to make sure that user is on an enterprise plan, or it won't run this function. So you can become really dynamic, and we didn't have to introduce some sort of middle layer step so that you can define what variables are and on all this stuff. You just write JavaScript, and it allows you to terminate that event much earlier, so you don't even have to process any of that stuff. It saves on other things like database connections and things for work that's not necessary.
That's awesome. Well, it looks really cool. Actually, I'm curious to check it out for some stuff myself. So yeah, and I saw apparently Nick is who we were talking about earlier. He's in the audience, and he's like I've got these ideas. I will bet you we end up with a two stack episode that with Nick Taylor building async workloads.
Let's do this, Nick. I'm for it. And just to say, hey, we released it not too long ago. We're working on a lot of cool enhancements to it, and I'd love to talk to anyone who wants to explore it more and try it out. And even if you don't want to go this route, if this concept of using event-based architecture and durable compute and stuff is interesting architecturally, I'm happy to talk about that. Using async workloads or not, trying to help make sure people are really capturing their moment on the web is like something I'd really love to talk to them about.
Nice. Yes, I will. So yeah, they can reach out to you. Do you have any contact information that was it on the slide?
Yeah. So it's
JavaScript.
Which is what my kids think I do. That's what do you think Daddy does? And they said JavaScript. So that's my tag.
Love that. It's a great that is a good story. So yeah. Okay. So reach out to you at JavaScript on all the channels. Yeah. Cool. Awesome. Well, thank you, Sean. This was great. Like I said, I'm curious to give this a shot. It definitely seems like simple enough that I don't have to, I can jump right in and start building things. So really good job on that. Thanks.
Thank you.